Here we have a Kenless dehumidifier. This is a 65-pint model. Picked this up at Goodwill a couple months ago or whenever it was. And during the initial test, it didn't seem to work. It's a Kenmore 580-536-50200 65-pint dehumidifier. It's got 22. Not very much of it, but it does have 22. And at this point, I figure anything with 22 is at least worth a couple minutes of time to see if we get it to run again. I don't know what the internals of this thing look like. I imagine this is probably a product of the 2000s. It's got decent weight to it. It might have a recip in there. It's definitely not worth hours and hours of time to make it run again, but I think it's worth a few minutes to check to make sure it's not something stupid. So let's go ahead and connect the power here and check it again, because I just don't recall exactly what the problem was. I'm pretty sure that the control panel operated in terms of providing feedback, but it didn't seem like anything turned on. So I'm going to go ahead and plug it in now. I'll keep you on the control panel so you can see what's going on. Alright, I hear a relay click when I plug it in. So it's doing something. It's measuring the humidity, and it says bucket full. Okay, so I'm going to go on the back here, and I'm going to let's see. I don't know what the bucket would have looked like, and I'm not really sure how the shutoff would have worked. It might be something as simple as it's off because of the way the bucket is supposed to be in there. We have this button here, but I don't really see how that would get triggered, other than the bucket just being present. I don't see any other switches in here. Let's see, does that light go off if I press this? It does. So the light go off if I press it. It's set to 40% humidity. It's 53 in here, so it should be ready to come on. Set to constant. Let's see here. Yeah, I don't know. The bucket full indicator is definitely off. And now it's on, so I don't quite understand how that would work, unless there might be a float mechanism that goes up and pushes that button in. I guess that would make sense. Which means it takes some stupid proprietary bucket. But it just seems to me like it's not running. So let's open it up and see what's going on here. Yeah, I find it hard to believe that the fan and the compressor both just died out of nowhere. You know, I feel like this is a control panel issue. So maybe what we'll do is we'll just wire everything straight to the mains and see what happens. I'm going to have to bypass that switch no matter what, hook up a drain hose, or just let it dump into a bucket or something, I don't know. We'll get there when we can find out that it runs. I don't know how this front cover come off. That might have it come off, but that's not the way I want it to come off. There's screws in the bottom. Let's see if we get those screws off first. We got a chintzy rotary in here. Oh, look at that. It's got a partial blanket on it. Oh, it doesn't look like it's high hours at all. In fact, it looks like it's going to be pretty low hours. Fan's got an oil port. Still spins pretty freely. It's a Hero compressor by LG, which I don't like. I think LG is garbage. It looks like our unit sits stuff sits in here. So, wonder if we can find the humidistat and like stick it in some water or something. But I ultimately just want a continuous run anyways. I don't care about those settings. I see a defrost. Yeah, the coil's not that rusted. I mean, it's in pretty good shape overall. Definitely no rot in there. Alright, I think what I'm going to do is I'm going to open up this control box here and let's see if we can just wire everything up to the mains. Now, if this didn't have a metal cabinet, I would say it's not worth the time of day, but I think this has the potential to be a halfway reasonable piece of equipment if we could get it to run. And then we have to disconnect this from here so that doesn't break. That would be a fatality if that was to break. And we have to disconnect this from up here. That should give us the cover back. That come apart easily enough. No, it's not in bad shape. It really isn't. I wonder if this is the humidistat. It probably is. That's kind of a weird placement because that's going to be our defrost right there, I think. Yeah, I don't see anything else that would be a defrost. Ah, here we go. This is what we needed. So let's see what we got here. Let's see if we can just hot wire this. Get rid of all this electronic junk. So we have, let's get our capacitor out of here so we can take a look. Capacitor is a oh, what it is. It's a 430. This is 25, 85, 21. Unfortunately, it's non-PCB, so it probably won't last that long. But looks like it's in okay condition. So I think what we need to do, well, see, we don't really know exactly. I suspect that if we just jumper these two together, that will give us compressor, because this is high side coming in, this is common to the wall, this is high to the wall, this is ground to the wall, And then this has got to be compressor. I would imagine these three are the compressor wires, right? Or is it the fan? Yeah, this is compressor. So we're going to have capacitor, common, capacitor run. Oh, it's all sticky. I wonder if that's been heating up. Capacitor, common, capacitor run, and then this should be power. So let's take a chance and get this off of here, and we're just going to jumper these two together, because I think that this control board is shot. Something's wrong with it. It's not, or maybe it could just be this relay that's bad, but you know, putting a couple wires together, that'll do. I have no interest in spending time trying to fix electronic control sets. I don't even like electronic controls. So we'll call this, let's see, I might be able to pull that off. We'll call that the high side. This has got to be the fan. Yep, so this is our fan. I imagine that well, I don't really know. Does it say what the wires are? What the schematic is? I think it does. Let's see. Can I just unplug this thing? There we go. Get this out of the picture because it's annoying and it's in the way and it doesn't even work. 2002. So this is old enough to potentially work well. Y1 ORBK. Do we have any of those colors? We do. We have yellow. We have yellow 1, which is going to the capacitor. Black is high, and then whatever that says is low. So orange. So I guess that's going to say red, I think, is low. So red and black are the windings, the two different windings, and this will be the common, and this is the capacitor. So I think what we need to do is we would need to take this off and connect this to the high side, and then connect one of these to the, or no, that's wrong. We would need to connect one of these to the high side and connect this to the common. I'm going to disregard the fan for now, because if the compressor doesn't run, then it'll be a waste of my time to make the fan run. So we're just going to disconnect all that. I'm going to take this off because I don't know what that is. Something with that stupid control board. I'm going to isolate the control board. So now we just have, we have our mains coming in, we have our compressor connection, and this, I believe, will give us compressor power. Let's just see if this have a schematic on there. Nope, I don't see one. Oh, it's got a schematic on top of the terminal connections. Common is white. Run is U. What the heck? And then start is, okay. Well, I don't know what the heck color is V and U. Well, whatever, it don't matter. Alright, let's give it a shot. So I believe if we connect these two together, which I think I can do if I just pinch it a little bit. We should be wiring the capacitor directly to the mains. In fact, what I will do is, let me try to pinch this on here, and then I'll grab the multimeter, or I have one here I can use. Grab the meter, and then we're going to we'll verify the continuity makes sense to a motor. Alright, I got it all hooked up. I decided to just cut it and put a nut on there because I figure if I get it to run, I'm not going to run it with those crimper things anyways, because I'm not going to use that control panel. So it was inconsequential to try to save it. It made no sense. So let's hook this up here, and we'll ohm this out and see what our plug is looking like. We should get normal readings through the plug now, if and only if the thing is good. So we have 1.9 ohms, which is not exactly what I would have expected. Now we got, oh, that came off. Let's see if we got anything to ground. Nope, nothing there. Nothing there, so nothing's to earth, so that's a good sign. I think we should just plug it in and see what happens. I suppose the worst that could happen is the power goes out. Alright, here goes hopefully something. Sounds like it's got gas in there. It's building head pressure. Oh yeah, we got cold. It's cooling. Yep, head pressure is building. I want to see that frost start to go away a little bit. We got no airflow, so it might not. Yeah, it's cold. Every rung is cold. I think we got a winner here. 3.8. Alright, so we need some fanage. We need a fan though. So let's see. The fan, we have the yellow goes to the capacitor. And then the black and red are the speeds. And then this is our common. So just go ahead and discard that because again I'm not going to use it. Black is high, red is low. We'll start with the low, because there's mixed opinions here, because on one end of the spectrum you want as much airflow as you can to keep the head pressure down, but on the other end of the argument it'll dehumidify better as the air moves slower. So which do you run it on? I don't know. We're going to start with low. So we need to take, that don't look too good. Get a good connection. What did I say it was again? Red. Red. We'll go to the high side. And then this is going to get a little complicated because I don't have, we don't have common anymore. Although what I could do is I could grab one of these and throw it onto the capacitor, potentially. Black is common. That's so stupid. Stupid. Stupid Samsung. I hate their products. They're all dangerous. I've never heard of so many instances of things catching on fire from one single brand besides Samsung. The telephones, the washers, the dryers, the refrigerators exploding. I mean, come on. What a disaster. Disaster of a company. Let's see here. What's the best way to do this? The easiest thing to do is going to be just to cut it here and then bind all three of them together. We got plenty of cord to work with. I think that's what I'll do. Obviously I got to do something better if I decide to use this anyways. So I'm just going to go ahead and do this. Cut this, strip this back, and we'll strip this back, and we'll combine these three. It's getting a little tight here to work with. Can't quite get this to grab. And there we go. Okay, so that should give us compressor and fan on low. And this I'm just gonna chill for now. Alright, let's power it back up. This time hopefully we get fan as well. The fan did not seem content. There it goes. Come out the top like this. That's stupid. The loudest flipping dehumidifier I've ever heard. Why is that so loud? thrown out. Jeez. 6.17 amps. That's about what it called for. It didn't call for 6. That fan definitely isn't running too good. Actually, the whole thing sounded like it was starting to stall out. I think we got to check the capacitor and see if the capacitor is still good or not. The capacitor might be drifting because that fan was not. To me, it didn't seem like the fan was running good. The fan should have started right up, and it didn't. Alright, so we'll check, let's see here. We'll check the hermetic side first, because that's easier when we got one thing on there. Alright, our hermetic side is measuring 3.5. That's not correct. 3 is not good enough. Should be 30, right? Oh, that fan motor's scorching hot. Yeah, something's definitely wrong with that fan motor. Oh, duh. I went fan the hermetic. That's not what we want. We want fan the common. Alright, common to fan. So this should be 4. We got 4.0. Okay. That's fine. And then hermetic to common should be 30, 29.9. So our capacitor seems to be okay. So my speculation is going to move on to the fact that we have a bad fan motor. Perhaps. Wow, I can't believe how hot that is. Just from 25 or 30 seconds of operation. Well, what we could do is, that was the low winding. We could try the high winding. Let's see if the high winding is any good. Actually, what we could do too, we could ohm out the motor, and let's see if we got trouble with this fan motor. And now we're starting to get to the point where this might not be worth. This thing might not be worth saving. Once I saw Samsung and LG as like, we're writing a different book here. So let's go from common to what do we say, to low. Don't need microfarads, we want ohms. 31 ohms, that's reasonable. Okay, let's try high. 152. That's not crazy. So then what the heck is wrong with this fan motor? try to ground. Okay, we're not earthed. So what gives? That's weird. Okay. Well, let's try to run just the fan. Let's throw the kilowatt meter on there and see what we're going to get. Power draw should be 0.35 amps. And if the compressor was drawing 3 or 4 before, and I was getting 6, that's drawing way more than 0.35 amps. Alright, so to get this fan to run, we're going to take off the compressor. Just for my personal reference, we know that the blue is the high side, and then the compressor's black was the common, and then the red was the hermetics capacitor. At least I think that's the way it was. I'll have to look back on the video, I guess. So for the fan, we need to play with this. Okay, so we're going to take, actually I need 2 of these. I need both of these to be in service here for this, I think. Right, because we're going to have, I got to fix the common one. So for this time we're going to take the common from that, and the common from this, from the fan. Connect those together to get our commons, and then we'll take that goes to the compressor, and we select one of these two. I think we said that red was high. No, black was high. Wait a minute, did I do it wrong? I might have done it wrong. Black is high and red is low. I don't think I had it connected properly, did I? I'm getting confused now. I don't remember what I did. Black is high, so black should be going to the high side of this. I wonder if I had it connected wrong. I'll have to look back on the video and see. Maybe I did a goof. It would make sense. It was definitely behaving like something was very wrong. Okay, so let's take black and put the black, which is the high side, to the winding, which is the high speed winding, and then we'll take, but then what the heck is the, okay, what am I missing here? Black is high, red is low, and then orange, the problem is there's a stripe through the thing and I can't quite see exactly what it is. Yellow is capacitor, black, and the telephone call. My telephone just ran out of charge. Anyways, jeez, my brain is really not working too good right now. I guess I should just go to sleep. What is it? Well, I can't tell you what time it is because the time is gone from the telephone. I think it's after 9 o'clock. I wonder if I had just wired up the fan wrong and did a brain fart. Because this is saying that black and red is a high and low. We know that yellow, which they're calling orange, or no, yellow is the capacitor, and then orange is the common. So I think that I screwed this up, because red and black, according to the diagram, should be our 2 fan speeds, our 2 windings, and then orange is the common, and then yellow goes to the cap. So I'm wondering if our problem here was a brain fart. Gosh, I wouldn't ruin this motor. That thing is flipping scorching hot. Alright, So now I think I've got it correctly. I think. Let's hook up our commons, and I'm going to check it one more time. Okay, so yellow is the capacitor. Capacitor run VN. White, which is grabbing the orange, which according to our diagram is the common. Common. And in black, which is winding for high, goes to black, which is the high side from the line in. That makes sense. I think I had a brain fart before. So now with this configuration, let's check our ohms and see what the plug reads. We should get a reasonable reading here for a fan motor. And we do. So let's turn this on and see what we get. Do we get flames or normal operation? Hopefully we get normal operation. I'm not in the mood for flames. That sounds much better. 0.35 amps, just what it should be. 41 watts. Okay. I'm going to eat that one and say I screwed that up big time. So that was operating properly. Let's try low. I can't believe I did that. Unbelievable. I'm going to have to go back on the video and see what the heck I did. I wonder if I put both windings on at the same time. I don't know what I did. Whatever it was wrong, and that was my fault. And I will eat that goof because that was just wrong. Alright, so this should now be low. It also seems correct. 30.32 amps, 37 watts, power factor 0.97. Okay, we have a good fan motor and a bad electrician. Okay, so now that that's resolved, let's go ahead and hook up the compressor again, and we'll let everything run by, all together. Alright, I rehooked everything back up. Hopefully I didn't make any stupid errors this time. So we should get low fan and compressor this time around. Perfect. We did. We got low fan and compressor. And we're going to watch. Our power factor is 0.97, that's good. Amps are 4.46, that's 2 amps less than what we had before, so that's good. That makes sense because we had about 3.5 amps before with just the compressor. Now we have compressor plus fan. That's a reasonable reading. If that wasn't doing that, this wouldn't be half that loud. Best we're going to get. Alright, so we're frosting up a little bit, which it's a rotary, it takes time to build the head pressure. Let's give it some time to see if the frost goes away. If the frost doesn't go away, then the whole thing just goes into the trash. It sounded like it had a decent charge to it, so I don't know. 4.6, 6.3. It's definitely got gas in there. I'm just not sure if it's got enough. Yeah, it's not getting quite cold to the ends. Oh, there we go. Looks like it was starting to defrost, but I guess it's not. Yeah, it's definitely cold just in the... Oh, there we go. It just defrosted a little bit. Alright, let's see. Let's give it some time. Want to build some pressure. Jeez, that is annoying. Alright, that's pretty good. Where is that rattling coming from? Something over here. In there. The compressor is actually pretty quiet. I'm surprised. Very surprised. There we go, that's what I was looking for. Head pressure is still building. We're up to 5.15 amps. It's just taking its sweet old time in typical rotary fashion. And there we go, we just lost all the frost. So, it's possible this has a good charge. fan motor is fine. I definitely did something wrong. Cooled right down 95, 97 degrees now. That's reasonable. Compressor is 135. It's heating up, but typical cheesy rotary, you know, from my least favorite brand. 5.23. It's still rising, so it's got to give it some time. Plus, it hasn't run in a long time either. Well, we're getting good temperatures. It's working. This is the discharge, or the return, and it is cool. It's not cold, but it's cool. It's definitely cooling. Yeah, I think we're good. 5.23 or 5.3, still going up. Yeah, it's going back cold. It is. It's going back cold. Getting some good heat out of here now, so it's warming up. I think this is going to be a good working unit with a bad control set. That's my speculation. Power draw 5.34 amps, 609 the watts with a power factor of 0.98. So all the motors seem perfectly healthy. 5.37, the head pressure is still building. Yeah, 89, coming out nice and warm. Going back 52, 54, that's acceptable. 55, 51, that's totally reasonable. Well, what do you know? It works. I don't like the brands on it. I don't like Samsung, I don't like LG, but if it dehumidifies, it's going to sit in a metal cabinet. I can trust it. So flipping loud though, what the heck? Actually, it's not that bad if it wasn't for that stupid rattle. There we go. I think it'll be assigned garage duty. I would trust this more than the one that's in there now. The one that's in there now is a newer Frigidaire. It's all plastic. At least this one, the case is still metal. Some aspect of the control panel is shot. Exactly what it is, I don't know, and quite frankly, I don't care. There's really no difference in the speeds that's detectable, so probably just set it up to high or low or whatever at random and just hardwire it up and put the cover back on and call it a good working unit. Nothing to clean, there's no dust in there. You throw a few drops of oil in the fan motor. And it's blowing out warm. Feels dry. It's working. Fan motor is 100 degrees, that's fine. Compressor is 160, 158, 154. Could take the blanket off, I mean, I don't really care what it sounds like. It's going to be in the garage. It's not making much of a sound difference. Take this off and see if it runs any cooler. It might. Use this for something else. That's the problem with rotaries, is that with the way it's designed, the case of the compressor is always going to be hot. It's just not ideal. But at the end of the day, they make cold. They work. Not great. I prefer reciprocating, but they work. Yeah, we're coming back 52. Put that right on there. It's tough. Tough to get it right in there. 49 going back. That's good enough for me. The whole coil is cold all the way through. Every rung is cold. Sweating. It works. I'm going to say charge is good. So yeah, it's definitely good if it's taking that long to stabilize. The compressor is made in Korea, so it's one of the better ones. I've seen these run for a long time. I still don't like them, but you know, whatever. Maybe it'd be a good garage unit. I'll throw it on a timer or something, let it run for 6 or 8 hours a day, and then that'll keep the garage humidity under control. I think I paid $12 for the thing. Not bad. It was a fun little project.